Solving the first one. Now your formula sheet will tell you y equals a to the power of x, and therefore the log of base a y equals x. So therefore this question looks like that. A is 6, x is y, and 3 is, so it's going to be 6 to the power of 3 equals x. So therefore it's 216. Simple, you tick.
What do you do with the log?
The log disappears because I'm going from this version to that version there. I'm unapplying logs. So usually I have this question here and I would apply logs and I would get that one. But I can go backwards. This one here, x to the power of 8 is that. So all I have to do is go, well, x is, technically it's plus and minus the square root of 6561, which would give you an answer of 3, I believe. Is that right? Yeah. And I believe it should be plus and minus, but because it's only an achieved question, you just needed the 3 would have been alright. Solve the equation. This is something that you could be asked to do because you should be able to factorize that second bracket. X minus 3, x plus 4, x plus 2 equals 0. So all I have done here, you too, here, all I have done with that second bracket is factorize that second bracket. Okay, that equals 0. And now anything times 0 equals 0, eh? So now x equals 3, x equals negative 4, or x equals negative 2. That was an achieved tick. Alright, now this one here wasn't done that flash. If I times this whole equation by 6, I get rid of the 2 fractions, eh? So that would be 2 lots of x plus 1 minus 3 lots of x minus 5 is less than or equal to 24. Some of you forgot to put that 24 part down. Expand that bracket. 2x plus 2 minus 3x. Negative 3 times negative 5 gives me positive 15. Okay, so therefore I've got negative x plus 17 is less than or equal to 24. So negative 7 less than or equal to x. That part there was your merit. And if you'd got to, I think you'd got to here, potentially it wasn't achieved. Here, this question here, a lot of people didn't actually understand what a reciprocal was. Like, the reciprocal of 2 is 1 over 2. The reciprocal of 5 is 1 over 5. So the reciprocal of x, 1 over x, sorry, 1 over x, not x. The reciprocal of 2/3 is 3 over 2. Okay? So it's just flipping it as a fraction, in other words. So when x is added to 1 over x, it is equal to 5. Okay? Don't like dealing in fractions, so I times everything by x. X squared plus 1 equals 5x. Is that right? So x squared minus 5x plus 1 equals 0. And therefore you chuck it into your x equals negative b b squared minus 4ac, and you'll get x is 0.21 or 4.8. Everyone happy with that? Okay, and the last one is an excellence question, so I won't go through it now. You got an answer. P was negative 2/5 or 2/5, one of those two answers. Either way, you got 12 over 25 for K. It's quite a tricky question to go through, so if anyone wants to see that, I will show you that way without the rest of the class listening. Next one, this is a must. You must be able to get these questions, because if you don't, then you're going to fail it. Negative power, we've gone through this with exponents, exponential graphs. X to the power of negative 2, well, that was just 1 over x squared. All right, so this one is going to be a to the power of 4 over 9 all squared. I just flip that fraction like I did with the reciprocal. And then it's a to the power of 8 over 81. Okay, achieved tick. This one here, multiply that bracket out to make it easier for myself. 400 y to the power of 16. That's a negative, so it's going to be 1 over to the power of a half. Now to the power of a half, that means the square root. Square root of 400 in my calculator is 20. When I'm doing that process there with brackets raising to the power of a half, I multiply. There is my answer for a simple achieved question. Simple in what I'm saying simple is that it's an achieved question. It's quite simple. It is not simple in any stretch of the imagination, but that is what you guys need to be able to do. Logs, guys, you need to know these ones as well. We went through these. Log 2 plus 8, well, that means times divide. When I'm adding logs together, it means times. When I'm subtracting them, it means divide. So 2 times 8 is 16, divided by 4 is 4. Log 4. An achieved tick. Next one, this proof, a little bit trickier to get your head around, but remember, 8 is 2 to the power of 3. 4 is 2 to the power of 2. So this is 2 to the power of 2n times 2 to the power of 3 over 2 to the power of 2 all to the power of n minus 1. Alright? And when I go here, this is 2n times 2 to the power of 3, 2 to the 2n times 2 to the negative 1. There's my 1. That goes on the top line and becomes 2 to the power of 4, which is 32. Now obviously I skipped a few steps within here and here, but that's what was required for an merit tick. P dollars is invested at R% interest. You can get that there. So $1,000 invested at 6.5%. So you've got, I think most of you had something like 1,000 lots of 1 plus 6.5 over 100. That, I think most of you got that. And some of you got to 1,000 times 1.065 to the power of n. Right. And then, incorrectly, some of you went to 1,065 to the power of n. Because when you've gone then, oh, okay, this is $3,000, and I've used logs to solve that, you're going to get like 1.1 years. Okay, now, those of you that did that, I put a big really in your test paper, because after 1 year she ain't tripling your investment, not at a 6.5% interest rate. Okay, so correctly what you guys needed to do was from here bring this over. Yep, it's $3,000 is 1,000 times 1.065 to the power of n. Okay, now it's this part here that refers to the whether it's tripled or what or not. Okay, so what we need to do is divide by 1,000, and we're going to go, well, that is 3, like that. That's the equation I'm trying to solve. Okay, doing this part here from this step to there, please don't do that. Okay, it's not what you do. You have to have it separate, because this is just the bracket here, all raised to the power of n. Okay, and that 1,000 just is what you've invested at the start. So from here I take the log of both sides, 1.065 to the power of n, what brings that n down the front, and so therefore n is just log 3 over log 1.065, which is, honestly, if you'd used your formula sheet you would have realized that n would be log 1.0653. That's what you would have probably done, and therefore on your calculator you would have done log of 3 over the log of 1.065, which is exactly the same as that anyway. Done that and you would have got an answer of 17.4 years. Okay, now answering that, if you had established, and if you'd established this one here, I gave you and achieved, giving me the answer, gave you a merit. Right, this was an excellence question as well, and it goes on this logic here. So the log of A plus the log of B minus the log of C, well, that's just the same as log of A, B over C, is it not? That's the log rules you have to remember. So because these all have the same base, we can just go the log of x plus 3 over x, I'll make those brackets big enough, equals the log of 2x. So because these are the same, x plus 3 over x is going to be the same as 2x. And so from there you're just trying to solve that particular equation. Times everything by x, and so you get x plus 3 equals 2x squared. That's a quadratic, so you make it equal 0. Alright, and that there factorizes to be 2 lots of 2x, x, 3, 1. That is plus, that's a minus. Alright, I haven't shown you how to do that, but you guys should know how to do that. Which therefore means I've got x values of 3 over 2 or negative 1. Okay. However, if you put that into your calculator, that will give you an answer. But what will this give you? So there's only one answer. And so you'd need to probably say something like, because can't do a log of a negative number, x must be 3/2. Alright. Now in terms of where you get your marks, being able to do that was your achieved. Getting both answers was a merit, and eliminating the incorrect answer was your excellence. So I honestly don't think this step here is beyond any of you guys. Okay, it is just an extension of this stuff here, which when we did, you guys worked through real quick. Okay, questions, expand and simplify. It didn't matter which way you did this. The easiest way to go about it is to do the bracket part first. X squared minus 2x plus 2x minus 4 all times x, and then this part here simplifies, so you just get that, and then you do that part and you x cubed minus 4x. Okay, that was your achieved. If you see this question, please gentlemen, and you are gotten achieved in this test, or you got not achieved in the test, make sure you genuinely take your time on it and make sure you don't make a silly mistake, because I can probably look around the room and who made a silly mistake with that question? You understand where you went wrong? Yep. Was it just going too fast? Yep. So slow yourself down with these simpler ones. Okay. And the next one, factorize. I've shown you how to factorize these. We multiply these two numbers together to get negative 40. What do we do with the negative 40? Seriously. We look for the two factors of negative 40 that add to that positive 3. So what are the factors of negative 40 that add to 3? 8 and negative 5. Thank you, Shota. So we write that down. 2x plus 8x minus 5x minus 20. Then we factorize that first two parts there. What's the common factor with 2x squared and 8x? We take 2x out the front, which leaves me with 2x bracket x plus 4. I want this bracket to be exactly the same, so I have to multiply that by negative 5 to give me negative 5x minus 20. And now these ones here form my other bracket, so I get 2x minus 5 x plus 4. Again, an achieved tick. Alright, simplify. Now, if I see someone do this again, I will probably have a look at my future in teaching. Please do not just cross out x's like that. Please just don't go, well that's common factor with that and that. So that's going to be a 1 and that's going to be a 5. So it's 1 over x minus 5. Please don't do that. Please don't do that. Because you're so very close to being right, but you've got there the wrong way. 5 minus x over x squared minus 25. Now I can only cancel up and down if I've only got pluses, only got times and divide. I've got pluses and minuses there, so I cannot cross out top and bottom. What I need to do is I need to factorize. Okay, now I factorize the top line because I know that if I factorize the bottom, I'm going to get x minus 5 and x plus 5. And that is not common with 5 minus x. So if I take the negative out and change the signs, then see how these ones here are now common? Now I cross out the whole bracket, which leaves me with negative 1 over x plus 5. Okay, that was your achieved tick. Okay, now in terms of achieved ticks, is that quite a hard one? Okay, in comparing it to the calculus, and the calculus required to get an achieved tick with some of these harder questions, to me that's probably a little bit this algebra one is a little bit harder to get an achieved tick than the calculus. Okay, but that's just me. The next one, the one I really want you to pay attention to, m, only one root, only one value satisfies the equation. So in other words, there is one root. And one root, when you see the word root, I'm going to be talking about the discriminant. Discriminant, b squared minus 4ac. One root, the discriminant, which is b squared minus 4ac, equals 0. Okay, so negative 6 squared minus 4 lots of 2 lots of m equals 0. Equals 0 because of this equals 0 over here being one root, the discriminant. So it's 36 minus 8m equals 0. So 36 equals 8m. Divide by 8 and you get 4.5 equals m. Now that was a merit tick. This part here was your achieved tick. Now to me, that achieved tick is easier than the above one. So that's why I really want you guys to understand this understanding about, the question about roots, discriminants, and when you can use it. Now same with the other one you guys just did. A lot of you went x squared here, x squared here. I'll just cancel those out. But I can't do that, because minuses and pluses there. So to answer that particular question, I have to factorize the top line and factorize the bottom line. If I factorize the top and I factorize the bottom, there will be something that cancels. They will do that. They won't do one that doesn't, because it's not going to help you. So x minus 7, x plus 5, all over x plus 7, x minus 7, all that is equal to 4. I can cancel those two out, which leaves me with x plus 5 over x plus 7 equals 4. Times everything by that fraction, so I get rid of the fraction. X plus 5 equals 4 lots of x plus 7. Now I expand that out, and that's just a simple linear equation that you are to solve. 3x equals negative 23, so x equals negative 23 over 3. Okay. Now, if you did that, there was your merit answer. If you're done to, I think if you got to there, that was your achieved answer. Alright, last question, excellence. Does not cut the x-axis means the discriminant, which is b squared minus 4ac, is less than 0. Okay, so b squared minus 4ac is less than 0. So here's b squared. So b squared minus 4 lots of, there's a, 2k minus 1 lots of c, k minus 1, less than 0. So 4k squared minus 8, k minus 1, k minus 1, it's less than 0. Expand this out. 4k squared minus 8 lots of k squared minus 2k plus 1 less than 0. So 4k squared minus 8k squared plus 16k minus 8 is less than 0. So I've got therefore negative 4k squared plus 16k minus 8 is less than 0. Take out the negative 4k, sorry, negative 4 out the front of the brackets as a common factor. You get k squared minus 4k plus 2 is less than 0. So I factorise this. Two numbers that multiply over the 2 that add to the negative 4. K minus 2. No, they don't. What am I doing? That's basic lies. There aren't two numbers that multiply to 2 that add to negative 4. So what I would therefore do is go back to this line just here and use my discriminant, sorry, not my quadratic formula. K equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that is negative 16 plus or minus the square root of 16 squared minus 4 lots of negative 4 lots of negative 8 all over 2 lots of negative 4. Negative 16 plus or minus the square root of, get my calculator here, 16 squared minus 4 lots of negative 4 lots of negative 8. That's going to be 128 all over negative 8. And so this gives me, that gives me two answers. K is negative 16 plus root 128 over negative 8, or K is negative 16 minus root 128 over negative 8. So I'll do that on my calculator. Negative 16 plus root 128 over negative 8 gives me 0.586, and if I change that to a negative, that should give me an answer of 3.414. But because there's no roots, I'm getting a little bit confused. So if I was to pretend to draw this one just here, this graph, that graph would look like that. And it has roots at 0.586 and 3.414. And so this graph is negative here and here. So therefore my answer is going to be K is less than 0.586 or K is greater than 3.414. Two answers. Okay, that is my excellence. Going back through what I need to do: discriminant correctly formed and reduced to a quadratic inequation. If I get to there, no, maybe I get to, I reckon that there might be an achieved tick. All the way down here is your merit tick, and understanding the particular context is your excellence. Alright?